we turn now to the topic of trigonometric functions, as you recall from algebra and pre-calculus, the trig functions are based on right triangles. We sometimes call this right triangle trigonometry. So if you imagine a right triangle where the diagonal is of course called the hypotenuse, that's the side that's opposite the right angle, um, we draw an angle theta here, and we refer to this side as the opposite side because it's opposite the angle theta, and we refer to this side as the adjacent side because it's adjacent to the angle theta. So we have the six trigonometric ratios based on combinations of these different sides. Excuse me, write that a little bit better, op for opposite. So what we know is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sometimes it's convenient to define tangent as simply equal to the sine of theta over the cosine of theta, which, as you'll see, when you get the hypotenuse to cancel out, that comes out equivalent to that comes out to be an equivalent definition. We also have here what are called the reciprocal functions. These are reciprocal functions, secant, cosecant, and cotangent, where secant is just the reciprocal of cosine, cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent. Actually, the names make it a little difficult to remember because you'd think that cosecant would be the reciprocal of cosine, but it works the opposite way. Secant is the reciprocal of cosine, and cosecant is the reciprocal of just sine. Um, So one type of problem that we can solve using right triangle trigonometry is of this form, where we say suppose the tangent of theta is equal to 2/7. So let's find the cosine and cosecant of the same angle. And of course, there's nothing special about cosine and cosecant. I just picked two random trig functions just to demonstrate the point. So the thing to do here is to first draw the triangle. We're going to draw a triangle whose tangent, we're going to draw a triangle where there's an angle theta whose tangent is 2/7. Well, what we know is that if the tangent is 2/7, then that means that the opposite over the adjacent sides must have a ratio of 2/7. So I simply put in 2 and 7. And I could have picked any numbers that have this ratio. There's no reason, for example, that I couldn't have made this side 2/7 and this side equal to 1. Or I could have made this side equal to 1 and this side equal to 7/2. Either way, I would get a ratio of 2/7 between these two sides. Any ratio that comes out to that will do. So now, using the Pythagorean theorem, we can find the hypotenuse, which is just going to be the square root of 7 squared plus 2 squared. So that's 7 squared is 49, 2 squared is 4, so that comes out to the square root of 53. So now that we have the lengths of all three sides, it becomes relatively straightforward just to read off any of the trigonometric relations that we want to. So we can say the cosine of theta, which is equal to the adjacent over the hypotenuse. That's the adjacent side to the angle theta. So the cosine of theta is going to be 7 over root 53. And the cosecant of theta is equal to the hypotenuse over the opposite, which is also equal, by the way, to 1 over sine of theta. So I could have, if I knew the sine of theta, I could have just calculated this by its reciprocal, but since we know the definition of cosecant is hypotenuse over opposite, we're just going to do it that way. So we'll say that cosecant of theta is equal to root 53 over 2. The thing about the right triangle view of trigonometry is that it's certainly useful, and we're actually going to solve during calc1 and in the next course, calc2, we solve a lot of problems that involve drawing a triangle, but it only gets you so far. So really, in order to get the complete view of trigonometry, you want to understand the unit circle. I've put up a unit circle here. You can easily look one of these up on the internet. If you Google unit circle, you'll get the exact same diagram. The point is that you really need to know the sine, cosine, and tangent of the basic angles on the unit circle, and those are going to be angles that where the angle between a particular angle and the x-axis is either 30, 45, 60, or 90 degrees. That'll be true whether we're talking about, let's say, this angle, which is 30 degrees, or this angle, which is actually that's 150 degrees, but as you can see, it's 30 degrees off the x-axis on that side. So, and of course, these angles, we're usually going to do them in radians in a calculus course. So you want to remember is that 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees are 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, and pi over 2 radians. Sorry, there's no pi over 5 that has any meaning, but that's just the way it goes. So you really want to start to think in radians. Now, I realize that if you're looking at this diagram, you say, well, this is an awful lot of numbers to remember. So I'm going to show you a couple of ways that you can remember what these numbers are, and I think that this will simplify it a lot. So let me show you this chart. We have here I've put up the basic angles in radians: 0, pi over 6, pi over 4, pi over 3, and pi over 2, and I've put up what the sine of each of those angles is, and the cosine, and of course we calculate the tangent by just dividing sine by cosine. Now you're looking at this and saying, well, wait a minute. This is just a chart. It doesn't make it any easier to remember, but I want to show you something. If you look at the number 0, here's the sine of 0 radians. That's going to be 0 over 2. And in fact, I can write that as the square root of 0 over 2. Use a little bit of a thinner pen here so I can fit in the chart. Here I have, for sine of pi over 6, I have 1/2, which I can write as the square root of 1 over 2. So, well, what's the big deal there? I'm taking the square root of 0 and the square root of 1, which are just root 1, which are just 0 and 1 themselves. Here I have root 2 over 2, and here I have root 3 over 2, and here I have 1, which is 2 over 2, but wait a minute, I can write that as root 4 over 2. So if you take a look at the progression of these angles from 0 to 30 degrees to 45 to 60 to 90 degrees, the sine is going to be root 0, 1, 2, 3, or 4 over 2. Now, if you look at the cosine, you're just going to get the same thing in reverse. You're going to get 1 is root 4 over 2, and then we have root 3 over 2, root 2 over 2, 1/2 is the square root of 1 over 2, and, oops, sorry, I meant to write that. That's a 0, actually. Excuse me. Correct that if you were taking notes, please. So this is going to be the square root of 0 over 2, like that. And then, of course, for the tangent, we just take the reciprocal, so that this is going to be sine over cosine, which is 0 over 1 equals 0. Here we have 1/2 divided by root 3 over 2. That's going to give us, it's a little easier to do if I take 1/2 times the reciprocal of root 3 over 2, which is 2 over root 3, and that just equals 1 over root 3, and that's the tangent. And we'll see here is that here I have the sine and cosine are equal to each other, so the tangent of 45 degrees, or pi over 4, is 1. And if I do the same division problem, I'm going to get root 3 there, and of course the tangent of 90 degrees is undefined because the cosine is 0, sine is 1. You can't divide a non-zero number by 0. You can't divide any number by 0, actually. So the next thing that you need to remember about the unit circle is whether the sine, cosine, and tangent come out to positive or negative numbers. So there's kind of a silly acronym that helps people remember this, which is, we can see that in this quadrant, recall the names of the quadrants, by the way. So that's quadrant 1, that's 2, that's 3, and that's 4. Here we'd say that all three of those functions, sine, cosine, and tangent, are positive, so we say that that's going to be A. In quadrant 4, only the cosine is positive. In quadrant 2, only the sine is positive. And in quadrant 3, only the tangent is positive, so some people like to remember this by the acronym CAST. I personally think acronyms are kind of silly because they don't really teach you anything about math. They teach you how to get math problems correct, but they don't teach you how to actually understand the math, so I'm going to do it a little bit differently. What you have to remember about the unit circle is that it is, in fact, a circle. In fact, it's a circle whose equation is x squared plus y squared equals 1. So the circle consists of points, and every point on the circle corresponds to one of the trigonometric functions. If I write this angle here as theta, this point is actually cosine of theta comma sine of theta. And let's call that theta 1. And if instead I do an angle like this, we'll call that angle theta 2, again measured from the positive x-axis. This point here, let's call that theta 1, theta 1. This is going to be cosine of theta 2 comma sine of theta 2. Well, now look at what we know about the positive and negative of those the x and y parts of that coordinate. We can see is that since we're in the negative x-axis here, we can see that the cosine must be negative. We can see the cosine must be negative, but since we're in the positive y region, we're above the x-axis, the sine of theta 2 must be positive. That gives us exactly what we see here, that there's only a positive sine, but there's not a negative cosine. And since the tangent is just the ratio of sine and cosine, the tangent also can't be positive in that quadrant. So if you simply remember that the point on the unit circle, that where this ray intersects the unit circle from an angle, where the ray is formed by angle theta, you'll be able to remember whether angles in a particular quadrant are positive or negative. So what we can see is that if this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi, you can tell based on what range your angle is in whether it is in fact positive, or whether it is in fact a positive or negative sine, cosine, or tangent.